AQA multiple choice questions, paper 3. Paper 3, I think, is 20 or 30 marks worth of multiple choice questions at the end of paper 3. So yeah, you do need to be practicing multiple choice questions. So question 1, a student rinsed the apparatus before starting acid-base titration. The results of titration showed that the volume of acid added from the burette was larger than expected. The conical flask was rinsed with water before the titration. That would make the volume of acid larger than expected. The answer is D. The burette was rinsed only with water. Therefore, it would appear that the volume of acid would be larger than expected. Question 2. A student devised an experiment to find the concentration of ferric acid in a sample of battery acid, blah, 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 which color change observed at endpoint each titration. And it says methyl orange is red in acid and yellow in alkali. That's pretty nice of them to tell us that. So it's got to be either B or D, because red acid and what happens. So a lot of students, including myself, fell for the trap of D, picking D, but the answer is B. Just think of it. If it's red to yellow, well, then why would it just tell red and acid, yellow alkali? The answer is red to orange, because we also know that a sample of diluted acid was transferred using a pipette and then a few drops of methyl orange was added. So red to orange. Question 3, which suggestion about rinsing the conical flask between each titration would improve the accuracy of the titrations? C, rinsing with water. Definitely not D, no rinsing with any liquid. How would that improve the accuracy? That would do nothing to the accuracy. Right, or actually maybe even decrease. So rinsing with water is the answer. Question 4, which is important in ensuring that the student experiment is safe. Answer is B, wear gloves when measuring out the battery acid. Now the C, definitely not wash hands before titration. That's not important in ensuring that the student's experiment is safe. D, carry the burette horizontally when collecting the apparatus. No, so it'll either be A or B. Do the titration in a fume cupboard. You would do that if it was like a harmful gas being produced, but this is a furic acid and a battery acid. You don't need to do it for this. The answer is B, wear gloves when measuring out the battery acid. Question 5, which suggestion would reduce the overall measurement uncertainty in the titration? Uncertainty being the error in using the apparatus. Use less concentrated alkali in the burette. And if you use less concentrated alkali, then whatever uncertainty is divided by that would lead to a reduced overall measurement uncertainty. Question 6, which suggestion would improve the chance of obtaining concordant titers? A, invert the volumetric flask several times after adding the distilled water. Now these ones are more calculation based multiple choice questions. Question 7. So what you'd first do is you do this divided by this, because I know the volumes changed. So I'll show you guys in the calculator, my calculator. So I do 5.00 times by 10 to the power minus 4 divided by 1.00 times by 10 to the power minus 2. Oh, sorry, no, the other way around here. 1.00 times by 10 to the power minus 2, since that is the bigger number. And you get a factor times by 20, right? So therefore, what happens in a 5? We also times that by 20. So the volume should be 100 centimeters cubed. But here's big but, because it says here's a big confusion between most students. Which of these is the correct volume of water that should be added? 100 centimeters cubed are what I should have as total after this. I start initially students provided with 5. So to get from 5 to 100, I need to add 95. So the answer is B. Question 8 was the percentage of uncertainty. This one, literally, all you did was 0.001 divided by 0.250 times by 100. That's it. 0.4%. Very simple multiple choice question. There's not really a trick for Well, obviously, if you don't know the formula or you don't know what to do, then you wouldn't get it anyway. So question 9, which of these pieces of apparatus has the lowest percentage of uncertainty in the measurement shown? A, volume of 25 centimeters cubed measured with a burette of uncertainty of 0.1. 0.1 divided by 25 times by 100, you get 0.4%. Temperature change of that measured with uncertainty of that, 0.1 divided by 23.2 on my 100, 0.43%. Yeah, I got that wrong because what I did was 0.1 times by 2 because 0.1 times by 2 divided by 23.2. Yeah, and then I got that. I was like, that's lower than that. I'll probably ask my teacher about that question. But yeah, the answer is A. Got the lowest percentage of uncertainty. Question 10. A measuring cylinder has an uncertainty of that. What is the minimum volume that can be measured? The percentage errors to be less than 0.2%. C. Answer is C. Question 11. Obviously, this question, another question I'll go through in a separate video since it is definitely a challenging question. Question 11. What's the percentage of uncertainty in the mass of solute used? So first thing you need to do is you need to find out the mass of solute used. So 10.13 minus 4.48. 5.65, right? Then 5.65, that's your mass of solute used, right? And I've got uncertainty of that, 0.005, 0.005. But remember, I've got two readings. I've got this reading minus this reading, so I need to times it by 2, divided by 5.65, times by 100, and then you get 0.1769%, 0.18%. Therefore, the answer is C. Question 12. What is burette reading for this transparent liquid? B, 24.30 centimeters cubed. Just gotta read it properly, and then yeah, you get the B. Question 13. 25 centimeters cubed sample of sodium hydroxide solution were taken by a pipette from a beaker. These were then titrated with an aqueous solution of ethanoic acid. The concentrated ethanoic acid calculated from experimental results was found to be lower than the actual value. Which of these could explain the difference? Lower than the actual value. Well, B, rinsing the burette with distilled water before filling with ethanoic acid. Question 14. Which pair of solutions when mixed would wax to form a dark brown solution? D, you got that sodium iodide aqueous plus Br2 aqueous. Question 15. Which observation would confirm that ammonia gas is released when solid ammonium chloride is warmed with solid calcium hydroxide? So first things first is it's your knowledge of, you know, your practical skills and your tests for functional groups. So this one, not test for functional groups, sorry. So this one, yeah, the red litmus paper turns blue. So you can already cross off A and C. So you're left with B and D. Red litmus paper turns blue. But this one says red litmus paper turns blue, damp red litmus paper turns blue when touched onto the solid mixture. This one says when held just above the solid mixture. Well, because ammonia is a gas, it's going to be a D when it just held just above the solid mixture, and then you can confirm that the ammonia gas is released. Question 16, which is best technique to remove silver chloride? That forms when aqueous solutions of silver nitrate and sodium chloride react. Filtration. Distillation, volatile liquids purified, not to remove something. Refluxing, that's definitely not it. Evaporation, no, yeah, filtration. Question 17, the temperature change from this to this during a calorimetric experiment. Uncertainty of each of the readings is plus 0.1 centimeters, plus 0.1 degrees Celsius. What is the percentage of uncertainty in the temperature change? So first thing you need to do is 21.8 minus 19.2. 2.6. Then I know the uncertainty in each of the readings is that, and I've obviously got two readings, this temperature and this temperature. So it's going to be 0.1 times by 2, because that's uncertainty, and I've got two readings, divided by 2.6 times by 100, 7.69%, 7.7%. Therefore the answer is D. Question 18. An aqueous solution of salt gives a white precipitate when mixed with aqueous silver nitrate and when mixed with dilute sulfuric acid. White precipitate, dilute sulfuric acid is going to be barium chloride. Question 19. Which of the substances react most rapidly to produce a silver halide precipitate with acidified silver nitrate? So what you should notice is that all of these, CH3 something, CH3 something, CH3 something, CH3 something, and it's testing your knowledge of this, really, CF, CCl, CBr, CI. And remember, faster substitution as you go down, so CI has a faster substitution as bond density decreases, you have faster rate of reaction. So which one reacts most rapidly is going to be the CI bond. Now, obviously, if you get that mixed up, then you probably get C because of the CF bond. But remember, that's the most strongest, so it's going to react the slowest with that because it's going to be a slower substitution. So the answer is D. Question 20. Which one of the following is a correct procedure for isolating a sample of hydrated copper 2 sulfate from a mixture of hydrated copper 2 sulfate and barium sulfate? Filter, crystallize, filtrate, dry the crystals, filter, dried solid, filter paper, add water, filter, dry solid, filter, crystallize, dry the crystals, filter, dried solid. The answer is going to be D. Add water, filter, crystallize the filtrate, and then dry the crystals. Question 21. In a test for halide in aqueous solution, dilute nitric acid is added before the addition of silver nitrate solution. Why is nitric acid added? It increases the concentration of nitrate ions. No. It prevents precipitation of silver compounds other than halides. And then question 22. A test for chloride ions aqueous solution involves adding dilute nitric acid followed by aqueous silver nitrate. Was the reason for added nitric acid? To prevent the precipitation of other silver compounds. And you can see how these two multiple choice questions, you know, these are probably, I'm assuming, from different past paper questions, but how it's the same concept. Why is nitric acid added? They've just reworded the question for multiple choice, added different options, and yeah. And obviously, if you know it, you'd spot it out. Prevents precipitation of other silver compounds. And that's why, you know, going through multiple choice questions, because a lot of the times they repeat questions or they just reword the questions so they're extremely similar. Question 23. The experiment was repeated at 20 degrees Celsius using 250 centimeters cube conical flask. Which statement is correct about the time taken for the cross to disappear when using the larger conical flask? Well, if you're using a larger conical flask, the time taken will be increased by using the larger conical flask. So you guys see. Question 24. What is likely to decrease the accuracy of the experiment? A. Rinsing the flask with acid before each new experiment. That is likely to decrease the accuracy of the experiment. Question 25. Which of the following will lead to inaccurate results? Transferring the standard solution of potassium manganate 7 solution from its original container to the burette using a wet beaker. And that makes sense. If you're using a wet beaker, yeah, it's definitely going to lead to an inaccurate result. Question 26. A student is required to dry a liquid sample of pentanoic acid. Which drying agent is suitable? Now, two drying agents I know off by heart: calcium chloride and magnesium sulfate, right? And if you compare any of these to these options to those, you know, calcium oxide, no. Calcium sulfate, magnesium sulfate, you got sulfate, so yes, that drying agent is suitable. Potassium hydroxide, no. Potassium carbonate, no. And yeah, just by using my two examples, B, calcium sulfate is the correct answer. That drying agent is suitable. Question 27. Which compound can be purified by forming a hot aqueous solution that recrystallizes and cooling? A hot aqueous solution that recrystallizes and cooling, well, organic compounds. So the organic compound is benzoic acid. recrystallizes on cooling. Yeah, D, benzoic acid. Question 28, which compound decolors bromine water in the absence of sunlight? Now this one I think is pretty tricky one. So if you look at it, which compound decolors bromine water in the absence of UV sunlight? Absence of sunlight. Well, decolors bromine water, so it's got to have what? What decolors bromine water? The carbon-carbon double bond, right? That's for alkenes. So if I look at A, that's a halogen alkane, 1-bromopropane. And look at B, that's benzene. It's not got those double bonds I'm looking for. I look at C, that's a cyclohexane. Again, I look at D, it doesn't look like it has any double bonds, right? CH3, CH2, CH, CH2. But if you count the number of carbons, 1, 2, 3, 4, hydrogen 3 plus 2, 4, 5, 6, 7, 8, C4H8, CnH2n, therefore it is an alkene, and it makes sense because there's the carbon-carbon double bond, and that's why you've only got CH here. Therefore it is an alkene, therefore it has a double bond, so it does decolorize bromine water in the absence of sunlight. Therefore the answer is D. And yeah, that one requires a bit more like trial and error, so we go from A to D.